This video is going to show you how to perform a denial of service attack as a non-root user to almost any Unix, Linux, or even Mac OS X system. Now, as always, practice ethical hacking techniques. A white hat hacker causes no harm. Alright, make sure that you are on a test system no one else is connected to, because when you run this, it's going to shut down the machine unless you've put in some things in place to prevent this type of attack from taking you down. So let's stick a fork in this server. It's about to be done. We're going to talk today about a technique called a fork bomb. Back in the day, we used to call this a rabbit or a rabbit virus or a rabbit process because essentially the fork process reproduces rapidly. Okay, so this fork bomb is essentially going to keep running itself, and it's going to rob the system of one or more resources. In our case, it's going to max out the number of processes, and it's going to monopolize the CPU utilization of the server. Again, I'm doing this on a test system as a non-root user. Alright, let's see how it's done. So a little bit about what you're seeing here on the screen. Here I have my virtual machine running Ubuntu Desktop Linux. In the background in this shell, I'm running the top command, and I'm having an update about every quarter second. Now that's a bit obnoxious, but once we launch this process, it'll spawn so many processes so rapidly before it essentially freezes up the computer. We want to see some dramatic results. A couple things to take a look at are the number of tasks and then how much idle CPU utilization we have. So we're in the 90s. Also over here on my host machine, which is a Windows machine, I'm running my task manager. So you can see my CPU is at about 10% and my memory is 87. Let's go ahead and create this fork bomb. So to do this, we're just going to define a function. We can name this function anything. Let's go ahead and name this bomb. And I'm not going to pass any parameters, so I'll just keep inside the parentheses blank. Now to define it, we need to put something inside of the curly Q brackets. So my opening curly Q bracket, this function is going to call itself. And then it's going to pipe the results of that to itself again, running in the background. That's as simple as the definition of this function. This function is going to recursively call itself and run itself in the background. So every time this process runs, it's going to create two more processes. And then those two more processes are each going to create two more processes. And then each one of those is going to call two more processes. So we kind of have this cascading set of functions just reproducing themselves. Now, the end of the command, I put a semicolon, and then I need to actually run the bomb function. So I'll just simply call it by putting its name in. And that's it. We could have even made this code even smaller by naming the function just B or something like that. But in just these few characters, we're going to actually bring this system to a screeching halt. Alright, so before I press enter again, we're looking at the total number of tasks, and this is going to happen fast, so I don't know if we're going to capture much data here or not. I've got my 90% idle. My CPU here on my host is somewhere around 12-14%. Alright, I'm going to go ahead and press enter. And here you can see, well, before it locked up, it got up to 1677. But you can see it's stopped updating. This command hasn't stopped running. The machine is just that busy. So it got up to a total of 1677. And in terms of being idle, the CPU being idle, nothing. It's being used in system states, right? So these are users, this is the system, it's actually creating more and more of these processes. Now the only way to recover from this is to kill those rogue processes. But since I can't do anything on the system, really my only course of action here is to actually reset the computer, to restart the computer. Now, when I created this virtual machine, I limited it to 2 virtual processors. So it's not using all of my CPUs on my host. Had I given it all the CPUs, I might be in trouble here on my host computer. So in this scenario, not only am I negatively impacting the users who may be logged into this Linux VM, I could also be negatively impacting other virtual machines that share the same host. You can see here, about half my CPU is being used. Okay, I'm also using a lot of disk activity for that virtual box. All right, so let's go ahead and restart it. When I restart it, you'll notice that almost right away my CPU will drop. So I'm going to come back here to my Oracle VirtualBox Manager. I'm going to right click on my Ubuntu machine. I'm going to choose reset. That's basically kind of giving it the 3-finger salute, control, alternate, delete. And here it says, do you really want to reset this machine? It may cause any unsaved data to be lost, and yeah, it will. So I'm going to go ahead and reset it, and we'll see what happens here. And it has reset it, and you can see my CPU utilization is dropping. The CPU utilization is going to kind of go back up along with the disk because I'm restarting this VM. That's taking some CPU. But I'll be back up and running. But in the meantime, anyone connected to that server has lost data. Just through issuing that simple function that did some recursion, calling itself and spawning more and more processes. So a very simple technique as a non-root user where you can bring down a server. So how do we protect ourselves against that? Well, there's a couple different ways we can do it. One way, and depending on the distribution of Linux that you're using, is to edit a file that's in the etc or etc directory, etc security directory. It's called limits.conf. And you can actually set for across the system or by user or even user groups the limit for the number of processes. All right, so that way if someone launches a program, and this can happen through no ill intention, somebody writes some bad code and it spawns a bunch of processes. And we can limit that. So I'll show you that file. We won't actually edit that file. I don't want to change the system across the system, but I'll also show you another way where you can temporarily do it for a session. All right, so my virtual machine has back up. I'm going to go ahead and log in as this test user. And again, things have kind of stabilized. My disk is coming down. My CPU is coming down. You know, I've recovered from this outage, but make no mistake, it was an outage. It was a denial of service attack. All right, so I'm going to go to the 9 dots menu here, and I'm going to go ahead and scroll down to my terminal. And let's just go ahead and cat out etc security and limits.conf. Okay, and it gives you a lot of good definitions on this file. If I scroll up here, you can see basically you're going to kind of say what you want to limit. So for example, for the number of processes, nproc would be our keyword here, the maximum number of processes. And so we would edit this file down here. So for example, if I wanted everyone in the group's student, I could set a hard limit for the number of processes to a value. Now you don't want to set this too low. If you set it too low, the user won't be able to do the work they need to do. And if you set it system-wide, the system may not even be able to do what it needs to do. Another way to do it temporarily is to use the ulimit command. So let's go ahead and type in ulimit. If I type in ulimit-a, that's going to show me all the different limits that are currently set. The one that I'm concerned with here at this time is to take a look at the max user processes. So if I did, I'm going to clear the screen just for readability, and if I did ulimit-u, you can see that right now 7,736 is the maximum number of user processes that I can spawn in this session. Let's change that. So we saw that the last report I got was somewhere around 2,700 tasks before the machine kind of locked up. So I'm going to enter in ulimit. I'm going to say 1,200. Okay. I'm going to issue the ulimit-u command again and verify that yes, in fact, it has been set to 1,200. Let's go ahead and enter in our fork bomb again. And again, I'm just going to define a function. And within that function, I'm going to call the function itself, pipe the results of that function out to the function again with the ampersand, meaning running it in the background. And then that's the end of my definition. That's the end of my command. And then the next command is actually I want to call that function. Okay, so here we can go ahead and press enter. And here you can see I've run out of resources, in this case the number of processes. It is artificially limiting me, right, to running any more processes. But I can go and I can still use the system, right? It's still going to use resources. It's still kind of hindering me to a certain degree, but at least the system is usable, right? So here I could enter the top command and let's update this every half second here. So again, still pretty much idle. It hasn't gone completely out of control. And I still have a usable system. So setting the limits could be one way to help harden your system against certain types of attacks, or protect it from good code that goes bad, which probably wouldn't be good code then, would it? All right, so this is just another example of a denial of service attack, typically perpetrated either accidentally or through the malicious action of an insider. Again, this is for educational purposes. Do not do this on systems that are not yours, that you do not have permission to do. Make sure you're practicing ethical hacking practices. All right, thanks a lot, and we'll talk to you soon.